Hello, Algebra 1. Today we are going to work on Lesson 3.1, Functions. So grab you some notebook paper, put your heading on there, make sure you have Lesson 3.1, and let's get started. Okay, for your warm-up, you are going to use a coordinate plane to plot these points. There are 6 points, and you can use the capital letter there to identify each of these points. If you need to pause the video, go ahead, pause it, and then come back and check your work. Okay, I'm going to go ahead and plot these points. Number 1, we have point A, and that is at 4, 2. So if you will recall, with an ordered pair, we have our x coordinate, comma, y coordinate. On the coordinate plane, we have our x-axis, and we have our y-axis. So we're going to go over to 4, up to 2 units. So we will plot point A, whoops, let me erase that, over 4, up 2, and that is point A. Point B is at -2, 2. So we are going to go left on the x-axis to -2, up on the y-axis to +2, and there we have point B. Point C is at -2, 0. So for our x-axis, again, we're going to go to the left, -2, and our y coordinate, or y value, is 0. So we're not going to go up or down on the y-axis. We're going to stay right there on the x-axis, and we're going to label that point C. Number 4, point D is at 2, -4. We're going to go over to +2 on the x-axis and down 4 units on the y-axis, and that will be point D. Number 5, point E is located at 7, -4. So we're going to go over to 7 on the x-axis and down to 4 on the y-axis, and that is point E. Number 6, point F is located at -6, -10. So we will go left on the x-axis to -6, down on the y-axis to -10, and that will be at the very edge there, and that is point F. So check over your points, make sure you plotted those correctly, and we'll go on. Okay, we're going to start out with some vocabulary. One of the main concepts in Chapter 3 are relations, and you need to know that a relation pairs inputs with outputs. So we're talking about a relation given as an ordered pair. The x coordinates are the inputs. The y coordinates are our outputs. Right along with a relation comes function. A function is a relation that pairs each input with exactly one output. So each of our x values will have exactly one y value. That's what makes it a function. It can still be a relation, but if each input has exactly one output, then we can classify it as a function as well. Okay, with those two definitions in mind, let's look at example 1. Example 1 says, determine whether each relation is a function. Explain. Okay, we have 4 different practice problems in example 1, and we need to know if each relation is a function, and then we're going to talk about how we can explain this process. So looking at A, we have 1, 2, 3, 4, 5 ordered pair. Now remember, in our ordered pair, we have our x value first, comma, y value second. So if I were to look at each one of these ordered pair, I need to make sure that each input has exactly one output. That's what makes it a function. So in the first ordered pair, I have a -2 for my x value. The second ordered pair has a -1. The third ordered pair has a 0, the fourth has a 1, and the fifth has a 2. Are any of those inputs, remember our x is our input, used with more than one output? No. Okay, so each value for x is only used one time. So in example 1, part A, when it says determine whether each relation is a function, we can say yes. So I'm going to come over here to the side and I'm going to list A, and I'm going to say yes, it is a function. Now for my explanation, I'm going to say because each input has exactly one output. Okay, let's look at example B. Example B also has a listing of ordered pairs. Let's focus on our x and let's go through each of these ordered pairs and look and see if we have anything being used with more than one output. So in the first one we have 4 as our x value or input. The second one has 8. So far so good. The third one has 6. The fourth one has 4. Wait a minute. Didn't we already have a 4? Yes. So this is telling me that 4 is being paired with 0 and it's being paired with the value 3. Can that still be a function? We understand it's a relation, but can it be a function if the input 4 is paired with more than one output? No. So to answer example B, we're going to say no. The relation, and I'm just trying to come up with a different way to state the same information. So no, the relation is not a function. And I can put my explanation in a separate sentence. So I could say the input 4 has 2 outputs. And I could restate those 2 outputs, 0 and 3. So that's another way you can explain why this relation is not a function. Okay, let's look at C. Now C is organized in a horizontal table, which is perfectly fine as well. You're going to see horizontal and vertical tables organizing your input and output, x and y values. So we're still looking for the same thing. We're looking at each input to make sure it has one output. So let's go through our x values and let's look and see if any of our x values or inputs are repeated. So as we're going along here, I start out with a -2, -1, 0, 0, 1 and 2. Okay, we have 0 being repeated with two different outputs. So 0 is being shared between the output or y values 5 and 6. Therefore, this relation is not a function. So we're going to come over here and we're going to add our response for part C. So, and I may not start out with yes or no. I could start out with just saying the relation is not a function. Because and what if I choose not to call it my input? What if I just say the x value has more than one y value? So that's another way you could explain or justify why the relation is not a function. And basically that one goes back to just the definition, you could say. Okay, let's look at the last part on example 1. And we have an input-output in a mapping diagram. So the version of part D is just organized differently as what we call a mapping diagram, where your input is separated from your output, and each of these are being connected to show what that would look like as an ordered pair. So that arrow is just telling us that the x value -1 pairs up with 4. The x value 3 is pairing up with 15. And the x value 11 is also pairing up with the y value 15. So this mapping diagram would be the same information as those ordered pairs: -1, 4, 3, 15, and 11, 15. Now you might say, well, these are repeated. I see two 15s, but the 15 value is my y or output, and there's no stipulation with our output or y value. So we still just need to look at our x values. Are any of those repeated? No. So we can say example D is a relation, or I'm sorry, is a function. So for our explanation, we can say the relation is a function because every input has only one output. Let me go ahead and clear that up real quick. Okay, so we just went through determining whether each relation is a function and how we can explain or possibly justify our decision with whether each relation is a function. Okay, let's look at example 2. Another way we could look at relations and functions in example 2 is using the vertical line test. So we have 2 parts here to example 2, and it says determine whether each graph represents a function. So if you have your ordered pairs put on an actual coordinate grid, you can do something called the vertical line test. You can take your pencil or pen and you can go from left to right on that coordinate plane, and you can look to see if a vertical line passes through more than one point on the graph. Now, you necessarily don't have to use your pen or pencil to do this. You can also visually look at the graph and determine if I connected any of these with a vertical line, would I have more than one point? Because remember, our vertical line is going to pass through the x-axis, which is our input. So if I'm looking at this and I see right here, this passes more than one place, I can say that this is not a function, because I could actually draw a vertical line through these points, which this one is coordinates 2, 2, and this one is coordinates 2, 5. And if they have the common input, our x is 2, then it is not a function. So for my explanation on part A, the graph does not represent a function. Represent a function. And for our explanation, so the graph does not represent a function. The explanation is we could draw a vertical line through those coordinates, or we could also say the input is repeated. So that's another way to explain. Okay, let's look at B. So if I were to use the vertical line test and I tried to see if this passed through any more x values, there's not any way I can draw a vertical line through more than one point on this graph. So each one of these is just hitting my vertical line at one spot. So that tells me my x value, or my input, is not being repeated. So if I'm able to draw a vertical line without anything crossing it at more than one spot, then I know this graph represents a function. So for my explanation on B, I can simply say the graph represents a function and if we want to explain that, no vertical line can be drawn through more than one point on the graph. That's a possible explanation. So no vertical line can be drawn through more than one point on the graph. Okay, and so it's just as simple as looking at vertical lines to make sure your x is not being repeated. That's how you're going to determine whether it's a function. Okay, before we go on to example 3, we are going to talk about a couple more vocabulary. So the first one here that pops up is domain. And domain is the set of all possible input values, basically our x value. So domain is our x values. So whether we have ordered pairs or whether we have points plotted on a coordinate plane or grid, we can still determine what our domain is by looking at our x values. Okay, we also are going to talk about range. So if domain is our x value, range is our y values. So that set of all possible output values, or y's, is our range. So our range is our y values. And something that I try to help my students think about to remember this, because it can be confusing, in your ordered pair you have your x and y. These are alphabetical. So when you think about your domain and range, domain is also alphabetical compared to your range. So in the alphabet, D comes before R, just like X comes before Y. Okay, example 3 says, find the domain and range of the function represented by the graph. So we are going to look at these ordered pair, and we're going to separate our domain from our range. So think about our domain is our x, our range is our y. Now we can write these out as a sentence. You might also see them written within braces to categorize the domain and the range. So let's look at part A on example 3. Okay, I have 4 points plotted there. So if you want to, you could go ahead and write those out as ordered pairs on your graph. That's perfectly fine. So if I were to write this first, just from left to right, this first point as an ordered pair, think about what our x value would be. Our x would be -3, and our y is -2. So that would be one set. Our next set, right up here, our x is -1, and our y is 0. Okay, the third one, over in quadrant 1, our x is +1 and our y is 2. And the fourth one, the last one, our x is 3 and our y is 4. Now, a couple things you could tell about this. Are any of our x values repeated? No. I could also look at the graph and think about the vertical line test. Nothing's passing through the x coordinate more than one time. So if we're looking now to classify or find the domain and range, we have our ordered pairs listed out. If you will remember, our domain is the x value in each of these ordered pair. So if I were just to take the x value and list them as my domain, this is what it would look like. Now, something else, and I'm just going to put a colon there, and I'm actually going to list these inside braces. You could also list them out in a sentence. I'm also going to put them in order. So I'm going to start with the least x value, which they are, if you read from left to right, already in order for you. So our smallest domain is -3. Then we move to -1. Then we move to +1. And last we have 3. Now we're going to go through the same process for our y value, or our output, or we're also going to call it our range. And we're going to go from least to greatest with our range. So if we wanted to do that, we would go from bottom to top on our graph. So the point closest to the bottom would be -2. That's the least value for our range. As we move up, we then hit 0, moving up to +2, and last we have +4. Okay, now we're going to go through the same process with example B. Now this one actually is connected, so it's a little different because we have a line of values now going on here. So let's talk about, for a second, let's talk about our domain, which is our x, and our range, for which is our y. So if we are looking at our domain values on the x-axis, we are kind of limited to where our x focuses on. So if I were to list my x values would only extend from the furthest point on the graph to the furthest point on the right on the graph. Sorry, from left to right. So for this example, if I were looking at my domain, and I wanted to put it as a sentence, I could say the domain is, now remember, x is our domain, so we're going to talk about a range of values here. So I'm going to put my x in the middle. The greatest value is 3. So that's going to go over to my right. The smallest value or least value is -2, as we can see right here and right there. Now, when I start to put my comparison symbols here, I need to look and see what kind of point that is. So it's including 3, so we want less than or equal to 3, and it's including -2. So we want less than or equal to, greater. I'm going to use the symbol less than or equal to, but x is actually greater than or equal to -2 as I read that. And then that's actually in sentence form, so I'm going to put a period there at the end. Now we're going to talk about the range. So the range is our y value. So we can actually see that the range's lowest point reaches there, highest point reaches there. So those are going to be my values for comparison with my range. And I'm going to put that as a sentence as well. So the range is, now with our range, we're going to use the value y. And the greatest it can be is 2. The least it can be is -1. So if the greatest it can be is 2, and it's also a solid circle, so we're going to include less than. And the least it can be is -1. And I'm going to put a period there at the end. So anytime our line or our points are connected with a line, we're going to use comparison symbols. Just for the purpose of not having to list every single value that would be found between those where they are connected. Part A in example 3, those aren't connected, so it's not extending. That's what we call a discrete graph. It is just those points of values. In part B, we would call this a continuous because those points are connected. That means it's taking in every value between these ordered pair. There's no way we could list every possible decimal or fraction, however you chose to list it, between those values. So we use comparison signs or inequalities. Okay, next we have some more vocabulary. Independent variable. Independent variable is a variable that represents the input values of a function. So basically, input value is our x. Independent means it can stand alone. So think about what the word independent means. This is also true for science. So if you have an independent variable in science, it's very similar. We classify it in math as our input value or our x value. Now, right along with independent, we have dependent variable. The dependent variable is the variable that represents the output values or y. Think about the definition of the word dependent. So if independent is able to stand alone, dependent relies or depends on the x value or the input. So just like science again, if it is dependent, it is depending on the independent variable. Okay, example 4. The function y equals negative 3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. So they've given us, in the example, our value of y, which is the amount of juice remaining after you take x gulps. So x is talking about our number of gulps. And they've already given us the function, so what it would look like. Part A is asking to identify the independent and dependent variables. And if you'll recall, our independent is our x, our dependent is our y. So look back up at the information that we were given and basically restate your x and your y as dependent and independent variables. So when you're asked to identify the independent and dependent variables, you're simply going to decide which is your x, which is your y, and you can state it as a dependent statement. So our y was the amount of juice remaining in the bottle, x was the number of gulps. So obviously the amount y of juice remaining depends on the number x of gulps. So for our response for part A, we're just simply going to state it as a dependent sentence. So the amount, and you can just restate from the question. So the amount y of juice remaining depends on the number x of gulps. So the remaining juice depends on the number of gulps taken. Okay, let's look at example B. The domain is 0, 1, 2, 3, and 4. What is the range? So if our x values are 0, 1, 2, 3, and 4, What are our y values? Now we have the equation that we can use to solve that. One of the ways you can organize this is in a very simple table or chart. If they are giving us the x and we're calculating the y, we're simply going to put into our table or chart the function itself. So y equals negative 3x plus 12. And we're going to calculate our y, or our range. So if I were to substitute 0, 1, 2, 3, and 4 in place of x, that's going to allow me to solve for y. So this would look like negative 3 times 0 plus 12. This would look like negative 3 times 1 plus 12. This would look like negative 3 times 2 plus 12. Then we have negative 3 times 3 plus 12. And lastly, we have negative 3 times 4 plus 12. And you can take and put each one of those into your calculator. So when x is 0, y is 12. When x is 1, y equals 9. When x is 2, y equals 6. When x is 3, y equals 3. And when x is 4, y equals 0. Now let's think about the question for just a second. Remember, x is our number of gulps. So think about, if you're drinking the juice, what is actually happening to the amount of fluid left over or remaining. So that's why our y is decreasing, and after 4 gulps we have nothing left. That leaves us at 0. So now we're going to basically restate this as our range, and I'm just going to simply put it in a sentence form. So we can say the range is, again, we can list it from least to greatest. This example would probably go in from just reading it from the table of information. So 12, 9, 6, 3, and 0.